Hi, James.
Hi, G.
Yeah, let's wait for a few minutes. I think these guys trying to join the meeting.
Hey.
Yeah, I think the Zhitao is running a few minutes late. I think let's wait for one more minute and then get started, and these guys will join later.
Right. Bad weather. Can't blame him.
Yeah. All right, James, I think we should get started. Maybe we should start from your stuff first. I'd like to kind of go through your implementation, whatever design for the user. Hey, Gilbert.
Hey.
I think Zhitao is going to be a little late, so let's start with James first and then see Zhitao can join. He said it's going to be a few minutes, but...
Okay, yeah, sorry I'm late.
No worries. Okay, so James, do you want to share your screen? Okay, I saw that.
Sure. Can everybody hear me?
Yes.
Okay, so I have a bit of code, basic stuff working. It's pretty straightforward. It's just like a few little tweaks here and there to actually get user namespaces working, because most of the infrastructure is fine.
Mm-hmm.
So as far as implementation goes, the goals are keep it simple. Let's not do anything too fancy at this point. And we want to focus on user namespaces with regard to security domains. We're excluding any sort of ID mapping for now. Two reasons for that. Firstly, I don't have a use case for it. And secondly, it makes it a lot harder. And I don't want to deal with that.
Yeah.
So in the model, we're kind of distinguishing not necessarily nested, but basically three API levels of user namespaces. We have the root namespace, which is the default user namespace of the host. We have the task group namespace, which is a user namespace that Mesos will create containers within. So it's going to be the parent namespace of the containers mount namespace and network namespace and that kind of stuff.
So James, when you mean task group namespace, you essentially mean the top-level containers namespace.
Yeah.
Because there might be multiple task group for a single executor. Well, I guess
no. A single executor would be the root of a container tree, and a container tree is a task group.
Oh,
right.
I see. Oh, when you say task group, okay, yeah, I think the terminology is kind of a little different because task group inside Mesos is really like just a bunch of tasks, and you can send multiple task groups to an executor. It's supported.
The terminology is I feel like the Mesos terminology isn't nailed down very clearly. So I was explaining this to a colleague using the term container tree, and we found that was a confusing terminology in that conversation. So today I'm trying task group.
Okay.
So maybe container tree.
Okay.
But whatever distinction between task groups and executor, what you really want is pod, right? Which has a clear definition in the industry. However, it is mapped to Mesos. I think you meant pod, right?
Yeah, we could say pod. Yeah, task group
in
is
this
a pod.
discussion, at least.
Yeah.
Okay. Yeah, I mean, I think we're trying to kind of decouple the container hierarchy from the executor task hierarchy. We want to decouple these two, but like some of them are like tied together. For example, the container is always tied to an executor.
Yeah.
Not anymore though. Not anymore though. Like with the standalone container being introduced, so not anymore.
So I mean, maybe this indicates that there's room for some sort of better description of the Mesos model,
right,
including terminology, so that we can discuss these things in a more coherent way.
Okay.
Anyway, so
keep going.
So there's the container. Basically, there's the container level namespace, and then there's what I'm calling a private namespace, which is a leaf, and the private namespace doesn't have any other namespaces created within it. So it's a leaf. So it's a leaf in terms of the security model. So basically, you set this as an isolator. When you enable the isolator, it just constructs the task group namespaces, the task group user namespace, the container tree namespace, and there's two flags in Linux info. One is private user namespace, in which case there's two levels. You get the container tree namespace, and when your task is launched, the task is launched into its own private user namespace, and that is a leaf namespace that doesn't contain any other kernel objects.
Okay, so why do you need two flags?
Why? So the share user namespace.
Yeah, I think I'm trying to think why you need two flags.
So the share user namespace. So I have an open question at the bottom for that. The share user namespace. The use case for that one is we want to be able to have tasks that join the root namespace and don't get a separate container namespace, because we want to still be able to support tasks that actually do manipulate the host.
Oh,
so
the parent. But if that boolean is set to false, would that be the same as the first one? So I get confused. Like if you set share user namespace to false, would that be the same as a private user namespace?
No.
Why?
No, because the distinction is what private user namespace means is that Mesos is that the user namespace your final task runs in will not be the parent user namespace of any other kernel objects. So in terms of the internal kernel namespace tree, none of this private user namespace won't be the parent of anything. So it won't. So when you construct a container, you enter you enter the user namespace and the mount namespace and maybe the network name and the PID namespace and all this other stuff. And the namespace, the user namespace is the parent of all these other namespaces, right?
Mm-hmm.
So that means that tasks in the same user namespace can have privilege over the other namespaces because they all have because they share a common parent.
Oh, I see. You're saying that.
So when you have a private user namespace, you're running a task within a user namespace that is not the parent of any other namespace, which means that it's not possible for that task to have privilege over any of the other namespaces that were used to construct the container.
Okay. What's the default behavior if you don't set any of those flags?
The default behavior is to run the task in the container user namespace.
Okay. Well, yeah, I guess I got a little confused about the container and task. You keep mentioning task.
So the task, the terminology. So maybe I'll change.
Maybe let's
task
use
script to container.
Yeah.
Container namespace. And the task.
Oh, are you talking about which executor are you talking about, or you're just talking about?
So what I mean by user task is the final program that is launched into the container. So it's either a binary it's either a binary that is running or it's an executor.
A binary or an executor?
So it's the command, right?
Mm.
So if it's an executor container, it's the executor. If it's a nested container, it's the container command.
So why do we need to distinguish the container user namespace and the task user namespace? Could they be identical?
So no. So we need to distinguish them because what matters in user namespaces, so user namespaces are defining a security domain. And when we have a private, when we run the task in a private user namespace here, what we want is we want to arrange for the task to run in a user namespace that is not the parent of any other user namespaces. Because in order to have privilege over some namespaced kernel resource, your task and the resource that you're having privilege against needs to share a common user namespace. So what private user namespace means is that we guarantee that there is no other kernel resource that has your user namespace in common. So if, for example, you are able to say you're running your program, it's in a private user namespace, and you were able to acquire some capability, right? You're able to acquire some privilege which was unexpected. That wouldn't let you manipulate the user namespaces that we use to construct the container, because those user namespaces, those namespaces, like the mount namespace, for example, is owned by a different user namespace. So you don't share a common parent.
Oh, okay. So maybe it will be easier if you explain the whole flow. You're saying that for the container, okay, you create a user namespace for the container, and then if you set this private user namespace flag to true, when you actually launch the executor or the task, you actually put that into another separate user namespace.
Maybe how about this explanation? So the container namespace protects the host. The task namespace protects the container.
Right. So that's kind of clear. Okay.
Okay. Let me put that in there.
Then the question is why? Oh, I see. The container namespace protects the host, and the task namespace protects the.
Yeah.
I see. But why not just treat container namespace the same as root? I don't think we run any code there, right? So we don't have any process launching that, do we? Because executors launch inside the user task namespace, not the or task is launched in?
No. So in the first implementation I have, everything launches inside the container namespace. And that's so the default behavior. The default behavior for the isolator is to launch everything into the container namespace.
And the issue with that is,
I guess there's no issue with that. It's fine, and it's going to protect your host.
It's going to protect the host, but it's likely that some tasks container might affect some other tasks container because they're in the same user namespace. Is that what you're saying?
Yes, and that might be what you want.
Oh, I see.
So if you have it, so in the current implementation, and I'm probably going to argue that, so the current implementation has a single user namespace for the entire container tree. I'm not, so this is not open questions, and I'm not convinced that there's like I don't really have a convincing use case to have different container namespaces down the tree.
I see. Yeah, it's kind of, you're saying if you want that, it's essentially you're saying that like some tasks in the pod is not trusted, and some other task can have sensitive information. Maybe we do have that use case, but yeah, I don't see that for now.
Yeah. So, you can say, hey, I have my task, it's in a container, the container has a user namespace, and the task has privilege within that container. And that's fine. So, okay, the task can do things to the container, right?
Yeah.
And then you can say, well, I have this task and it's in a container, but I really don't want it. I really don't want it to do anything to the container, and that's a use case for a private namespace.
Yeah. So does that mean like we don't even need these two flags?
We could assert that everything gets a private user namespace. That feels fairly restrictive, though.
Oh, I see. You still want some container to join the host user namespace. Is that
so? There's two. I mean, basically, there's two things which I expect people to actually want. So there's the private user namespace, which is I'm running something that I really don't have any confidence in. Right? I don't want this to have any. I want to protect both the container and the host from this task. That's what private user namespace means. And then there's root. Then root user namespace is the opposite. It's when I'm running a task where I do want it to have privilege on the host itself. And that's and that's in the straw man here. I've said you would use the share user namespace flag there. So whether we call that share user namespace or root user namespace, I'm open to suggestions. Share user namespace is more consistent with other API booleans, but root user namespace is really
what does that mean for nested container? Have you thought about this? Like, what do you mean? What does that mean if you say I'm launching a nested container and set share user namespace to true? Is that share with the parent container?
Well, yeah, we would have to make that. If we call it share user namespace, we would have to make the semantics of that consistent with a share pig namespace flag.
Okay. I see. Okay, I can understand that flag. I can definitely understand the share user namespace. The private user namespace. Okay, so let me put that in this way. So what if you set share user namespace to true, but private user namespace to true as well? Is that a failure, validation failure?
No, that would be fine. So if you set share user namespace to true, and you're the root of the container, then your container will be constructed in the root user namespace, and your task will be launched into its own private user namespace.
Ah, I see. Got it. Okay.
Sorry, I missed that part. Can I ask another question? So the Linux info is attached to the container info, which is used whenever you launch a container, whether that is an executor container or the nested container. So that's why in there, even with a shared pit namespace thing, you only say the parent versus not. You don't say the root because you don't know if you're accessible, if the root is accessible to you, right? If you're already under nested container, then your parent is already not root. Is the root still available to you?
My understanding, sorry, James, correct me if I was wrong. My understanding of this is user namespace is like a special namespace. So there's a relationship between like other namespaces compared to like, say, you can say amount namespace is under that particular user namespace. Because of that kind of complicate the flag on that we cannot do similar to what we do for like pin namespace. No, because you do have a situation where like you want the like say you have two nested container under a top level container. You want these two nested container to not affect each other. Wait, hold on.
So I think to answer Jan's question, yes, it works the way. Yes, this can work fine. So if we implement share user namespace, then what this meant to that would be join the user namespace of your logical parent. So if you're an executor container, you would join the root user namespace. If you're a nested container, you would join the user namespace of your executor.
Right. Yes, that makes sense to me.
And if it's false, then you would get your container. You would get a new container, use a new namespace, a new user namespace for your container, irrespective of whatever level of nesting you're at.
Okay, so then that okay, so I got totally confused. So you're saying like just one flag is sufficient to support user namespace?
Sorry, can you repeat that?
So okay. So I guess the question is for pin namespace, we only have one flag, which is whether you share with your parents' pin namespace. Can we do the same for user namespace or not?
No.
The reason
because we have this extra layer. We want to have an extra layer of namespaces to protect the container from the task, and that situation doesn't arise with namespaces.
Right. So the distinction between the container and the task is that what you said, the kernel objects versus only the task process.
Right.
So when you clone, let's say if you're launching a new container and you clone and you have this whole list of namespaces specified, and now the user namespace is in it, and then I guess that's your container username and container user namespace, right? Which has other namespaces when you clone.
That's
and
correct.
Then when you clone, you have Mesos containerizer launch there, which then would fork exec your process image. So what else is this? How do you achieve this private user namespace after that? Basically, starting from that point on, how do you do additional isolation?
So when Mesos is launching a task, there's the clone, which happens in the launcher, but then later on you run the containerizer you do Mesos containerizer launch, and this is the final stage to actually executing the command. Right. So at that point, when you execute the command, you have to construct a new user namespace.
My point is why? Why do we need to do that? Assuming that, like, let's say you already create a user namespace for the container. Why do you need another user namespace for the task, given that the container is all Mesos code? I mean, it's not executing anything.
Because the container, the container is made out of namespaces, right? The parent of those namespaces is a user namespace, right? So when I launch a task, when I run a program whose parent is the same user namespace as the namespaces that are constructing the container, then that task can acquire privilege over the container.
Over the container.
Because they share a common because they share a common user namespace parent.
And why is that an issue? Because they can.
Because if I don't trust the task, if I don't trust the task, say I'm the suspicious person and I think that this task might be able to acquire privilege that I didn't explicitly grant it. If I'm suspicious, then what I would do is I would say, well, what I want to do is I want to say, hey, the task has its own user namespace, and that user namespace is not the parent of any other namespaces in the container. So if the task was able to acquire privilege, it wouldn't have any privilege over the container because they have disjoint user namespaces.
Yeah, but I thought sorry, what I thought like when you want okay, I'm thinking about the like when you want to launch another task in that, like say the top level container is executor's container. And then the executor wants to launch a task container under that executor through a nested container API or directly just fork exec. If it's default executor, just hit the agent API to create a nested container. So the nested container is under a different user namespace already.
Right. Yeah.
Then you launch the container will actually like fork exec the actual task in that the same user namespace as that nested container.
Yeah.
So that task in that nested container won't be able to do any change because it's still contained in the container's user namespace. Unless, I guess the case you want to solve is unless there's another nested container underneath that like a level 2 nested container, like level.
But this is the same case, right? There's a user namespace which is the parent of the container, right? If the task has the common parent as the container, then the task can acquire privilege over the container. It doesn't matter how deeply the container is nested. Nesting is just a logical notion.
I see. No, I sort of get it. So you're saying like it doesn't make sense for the task itself to get the privilege over the container because there might be some other task launched under that same container, and you don't want that to affect the other task.
Well, even if we just go, say we assert that every container gets its own user namespace. For an unprivileged task, for an unprivileged task, I want that task to have a unique user namespace so that it can't acquire any privilege over the container, because I want to reduce the risk of it being able to break out or manipulate the container in some way.
The consequence of a breakout is not that big. I don't know, like what that task can do because it's still contained in that container's user namespace.
But I don't want to have that task manipulate the container.
I see. Okay, so you just might be super. Okay. Now I got it. Okay.
Yeah. So the distinction is, if it's in a private user namespace, you have less ability to alter your container.
So is user process in that container, but not in that task, basically just the Mesos containerizer launch helper?
Yeah.
Which has a...
Yes.
Can you hear me?
Yes.
Okay. I was just doing the comparison with the PID namespace. Actually, in this isolator, there is only 2 levels, right? Like what you try to introduce here is a 3-level namespacing feature, like root versus container versus user, and for the PID namespace, for example, there is only 2 levels, right?
No, PID namespace there can be multiple levels. So we have a flag called like share with parent. So if you set that to true, the pin namespace will share with the parent container. We can have more than 2 level of nesting containers.
Okay, but I mean, you can only do the same feature that here with the share parent or share something.
Share with parent.
But you cannot. I mean, create another pin namespace for the task properly, separated from the executor and the container and so on.
Well, it depends on which executors. If you use default executor, then that's separate. But if you use the old style command executor, then it's not.
Okay.
So the command executor is kind of old, like legacy executor that do its own fork exec and don't really leverage the user namespace. Sorry, not the pin. Sorry, don't create the pin namespace for the task.
Okay, so the behavior is different if I change the.
Yeah, I think that the goal is trying to move to the default executor scenario, and whenever you want to create a container, nested container, you need to hit the agent API to get that created, and then agent will properly set up the nesting for the pin namespace.
Okay, because in my vision, I mean there is clearly similarities between user namespaces and UID namespaces, for example, PID namespaces. Sorry, like you can, as a naming convention, generalize the fact that there is a child and parent, because we were talking about nested containerization, etc. So why not changing the naming? Instead of root calling parent and instead of user task calling child or
I think that's
like that.
I think if I understand correctly, that's the intention from James, that the flag like share user namespace share with parent essentially.
Yeah, but Pierre's correct that there's this third layer, right? So share user namespace is parent and child, which we have already that concept in the PID user namespace. But the additional one that we want for user namespaces is this private, which is nomenclature.
So James, that brings an interesting question. Should we do the same for pin namespace?
No, you can't do the same with PID namespace because PID namespace basically requires a new amount of proc and everything. So,
but from a security perspective, I probably still want this feature because I can have the same argument saying that, right? Just ignore the implementation details. Like from a security perspective, I probably want my task to not be able to see containers PID, container like the pin namespace of the container, like the init process. I guess we probably need to allow both.
How can you not see the init process? You have to have the init process.
Well, I want the init process to be, wait, hold on. So I want the init process to be my tasks. Like, for example, I want to launch system D.
Yeah, that was my point, basically.
Okay.
I feel this is the same thing. Maybe we should think more on this. Maybe do the same for pin namespace. Oh, allow both, basically. I think for pin namespace, some people want to say, hey, I don't want to manage my own init. Please do the init for me. Or some people just prefer, like, say, I want to do my own init. I want to launch system D. So we probably should support both. I think we definitely need to support both.
Yeah, I think I agree with the use case of being init or being able to do your own init, but I don't know that this is the right model for it.
Okay, if that's...
I think you can probably do that within the existing model of parent and child PID namespaces.
Yeah, if you think that's not the right model, then I'm going to question like why you think that this is the right model for user namespace.
Because user namespaces are different. So we can talk about. So I don't know what the API looks like. We can talk about what the API doesn't have to be a flag. The API could be something different, but ultimately you can separate these things out in a way that's completely transparent.
So I guess maybe what G was asking has to do with what I was commenting on the doc, which is can you achieve the same thing with additional levels of nesting, or nesting in the sense of Mesos containerizer launch, or in this finer grained different actions to do when you're launching this level of container?
I not sure I know what you mean.
Because you see that so I guess it's probably helpful to when we're talking about or writing about container launches to separate that from Mesos executor task, whatever the Mesos terminology and workflow is, and basically just think about you have this container to launch and you want to put a process into the container. Forget about tasks, because ultimately this thing can be arbitrarily nested, right? And even if there's no sense to use it that way, it's I guess we're a little bit confused when we're talking about containers and the tasks at the same time. Whether so, for example, if you the health checker model, which is you launch a nested container by the default container by the default executor, but then your health checker is nested under not the executor level, but under the task level. That's a third level. So all of these nesting levels, how do they affect your reasoning of security and the use of private versus shared?
I think, okay, so in Mesos, when you're talking about nested containers, it's just logical nesting, right? You just have, it's just a logical nesting of containers. So, oh, this is some internal notion of a tree of things that we call containers. And when you have the private user namespace here, it's not a container. What you're doing is you're leveraging the user namespace security model to protect the container from a task. So it's a completely different thing.
I understand that, but I guess could the question be that, okay, so if you're concerned about this level being not protected from the level down, could you launch a container, nested container, which for security you launch another nested level, and in between levels you have shared being false? Would that achieve anything?
No, it doesn't do anything, because the container is constructed out of kernel objects. The parent of the kernel objects is a user namespace. You launch a task with the same user namespace parent. It doesn't matter what you've done internally to Mesos to keep track of this logical tree of containers. What matters is the relationship between the kernel objects. Okay. So you can make as many nested containers in the Mesos nested container model as you want, but it doesn't have any effect on how the actual security properties of the system.
Okay, so I think we should probably set up a follow-up meeting on this. I think, or maybe we should also. I feel like I'm probably need to do some reading on this doc first before I comment on this. Anyway, so James, do you have anything more than this API?
No. So down the bottom, there's links to the Jiras, which
okay.
I have an implementation for 8.1.4.2, and I'm kind of running some basic test cases.
Can you share the doc to the Slack channel, containerization channel?
Sure.
Because I haven't seen this doc before.
Sure. I only wrote it this morning.
Okay, sounds good. So I probably the next step is to comment on this doc and think more on this. I don't think 1 hour is half an hour is sufficient for this. Probably need to think more on this.
I thought it would be 10 minutes. So
okay, yeah. Sorry about that. I think we do have another agenda, so I want to switch to a different agenda, and we can follow up on this maybe next time or during probably next week. I do want to comment on this. Cool. So Jitar, are you on the line? So maybe we should switch to the GC stuff.
Yes, I'm here.
Hey.
Gilbert, you there?
Hey.
Hey. So So what's the agenda? Are we going to just do a demo, quick demo, and discuss something else?
I guess we can do a quick demo just for a couple of minutes, and then we can check out the auto design in our design doc, the auto GC design.
Okay. Let me see if I can project my screen. Can you see my screen?
Yes.
Okay, so this is just a quick demo about what we have right now for the image GC work. So right now we have implemented most of the things under the inside the containerizer, from containerizer to the image provisioner to the Docker store. So right now we are able to trigger image GC for the Docker images through experimental operator API on the agent.
Mm-hmm.
So let me get started. Let me clean up the worker. Start from scratch. Where is my node? So let me start an agent and a master. Okay, let me confirm these things are connected. Now let me use Mesos execute to run like 2 tasks on the machine, on the agent, which just sleeps forever. One of them using the default Ubuntu Docker image, and the other would be using my SQL Docker image. Go back to my agent log. See, we are fetching all the related images. Let them finish. Okay, and we can use this this HTTP request. It pretty much just call the operator API called print images on the agent. Make sure it runs. Okay, it's sent through. I think in this case, because both tasks are running, both images are considered still active. So we are not going to delete any layer right now. In verbose logging, they are printed out. Now let me stop one of the tasks. The one stopped would be Ubuntu. And try again. Let me go back to the agent log. We see that, I think we see that from the verbose logging, you can see that we decided to delete a bunch of layers from the system. And we also, I think there's also log lines here say we are marking a couple of, I think there should also be logs indicating that certain other layers that the MySQL image is using are marked as are kept during the GC. Now I think if I
see.
Other one, as for both of them, run another GC. I think we should not mark anything active anymore. And if I stop this, Mesos, Docker store, this should be empty.
Okay.
I think cool. If I LS on this previously, this should not be empty. This should have a bunch of layers here.
Cool.
Mm-hmm.
Cool. So just one question. So when you do the HTTP API, the response is always 200. Okay.
Yeah. There is only one chance it can get a 400 is when we do not have all the. So there was a couple of dependency patches requiring we to checkpoint the relative information.
Yeah.
These information are incomplete. We return the 400. So we cannot safely do an image GC right now in the store.
I see.
Mm-hmm.
Okay. And do we have a way to show like how many layers being deleted?
We don't have that right now. It can be trivially added as a counter.
Yeah, add a matrix for that at the very least.
Yeah.
Okay.
I think we should.
Zhitao,
Yes.
so is there any GC without me calling the API?
That is what Gilbert is proposing we discuss today, like come up with a policy to do a automatic GC based on certain policy or heuristic in the agent.
Yeah, I mean, I'm thinking for my use case, like how I wouldn't know when to call it. So the best I would do was maybe set up a cron job to call it all the time, which seems like Mesos could just do that for me.
Yeah, so that's what we want to discuss next, I think. Gilbert, do you want to yeah, thanks, Jita. I think that's great.
Stop sharing.
Yeah,
So,
at least right now, you know that if the images which no longer is valid, you can do that.
Yeah. Well, I think so. James, to your question, so one simple way is like you can monitor the disk pressure. If it reach like a certain threshold, you can just call that API.
How would I monitor the disk pressure?
You just do a DF.
No, but Mesos has a notion of disk pressure.
Yeah, so that's what we are trying to.
So would I do have that? I mean, I can see if I could monitor it if Mesos tells me about it, but
right.
Otherwise, I'm just reinventing.
Yeah, true. So yeah, that's Gilbert wants to discuss this meeting.
Yeah. So we only have like 10 minutes, so maybe we can quickly go through the display of the auto GC. It is a basic one. Oh, before that, one thing to note, it is like if you want to use the GC for Mesos containerizer, you have to, and your cluster upgrade from a previous version to 1.5 or later, you have to drink all the container on the agent. Otherwise, the GC gonna be disabled. We have no way to like support backward compatibility for the legacy running containers.
Well, you're saying like you want that endpoint cannot be used because the endpoint will return 400. Is that what you're saying?
Yeah.
Okay.
I think both endpoint and whatever auto GC we would add, they cannot be safely performed on the containerizer because.
I see. So, and the reason for that is because you don't have enough checkpoint information in the previous versions. Is that the reason?
Correct.
Yes.
Oh, okay.
Yeah. So we're gonna document that.
Mm-hmm.
Yeah, definitely document this.
Mm-hmm. Any question?
No. Do you want to go through the auto GC policy thing?
Yeah. Let me share my screen.
Okay.
Can you guys see my screen?
Yep.
Okay. So basically, we already have a discussion about the auto GC. So it's hard to it's gonna take some time to decide a truly auto GC. So right now here the auto here means it is a very basic support for auto GC, and we just introduce some heuristic logic in the agent code to allow operator to specify some agent flag to so that we can trigger the image garbage collection periodically. And the discussion starts from what's the policy we want to trigger the GC. It can be type-based or size-based, and it can also be a combination of them with some other factors. So maybe in the future, when we decide the unified artifact store, we can introduce some like auto GC policy protobuf to allow user to define GC policy for image layers. And for now, we just quickly go through these two option, and the size-based makes more sense to us because for type-based, if someone just want to like trigger the GC periodically, why not just deploy the clone job and then trigger the GC weekly or monthly? So for the auto one, we prefer to go with the size-based. And so right now, if you guys look at the current executed sandbox GC, in our executed sandbox GC, we will schedule sandbox for garbage collection, and then we have 2 agent flags to control that. One, it is the sandbox GC headroom. Another is the watch interval. And we're gonna introduce similar mechanism for the image layers. And basically, we have 2 options here from our design. One, it is like introduce 3 agent flag to control the headroom and the interval of the GC. The headroom means like this threshold, because the agent monitor this usage from the Docker store directory, and once it reach a specific percentage, so for example, the headroom, it can be like can be 0 to 1, and if it's like 0.1, it means like if the usage of the disk up more than get up to like 90%, it will trigger the GC automatically. And the watch interval means like how frequent we check the disk usage. And so these 2, it has to be like both set or not set. And we also have another flag to control the excluded image. So it means like it just matched the operator API. So right now the operator API, we did not implement that yet, but in the future we will add an excluded image. It means an image, even if it is not used by any container on the agent, but we will still keep it and cache it on the agent. So, yep.
No, I guess my question is the headroom and all of the calculation, is it based on a size, or basically the remaining free disk space of that volume of that disk? I thought there's going to be like a size for the disk image for the image cache.
It is not size; it's the percentage of the disk usage.
Of the entire disk usage, right?
Yeah.
But what if I don't want the entire disk to be used for the images? So I have to set a headroom based on that?
Yeah, so I think then you have to calculate the headroom in a different way, based on what. Right now, we don't have a mechanism to enforce the disk usage for a store, right? So right now, we don't have a way to
Yeah,
I see. So I guess it's not like this wouldn't work, but I can see that this is kind of modeled after the sandbox GC and not the fetcher cache. Even though sure we want to improve, but at least the fetcher cache, you have a designated size, and you know the size of the things you put in there, and based on least recent use. Of course, there's more things to consider here, but you basically see how far away are you from that size, and you do GC based on that, and not the disk pressure like sandbox GC, because for that you want to leave them as long as possible, because for future investigation you might need these artifacts. And this cache looks to be more like the fetcher cache, which if it's no longer used, then, and if retention, a desire of retaining it for a long period of time, I guess it's not there. So there are 2 ways of thinking about this, right?
Yeah, I think that's a good point. Yeah, I think that's a good point. We should take a look at the fetcher cache flags. Is there a size for the fetcher cache? And then, but we don't have a GC. Do we have a GC for fetcher cache?
No, yet. It is.
I think it's recently used.
So yeah, I think for fetcher cache it's easy because there's no the package is the package. There's not like layers which could be shared and all that. So fetcher cache has a size, and the easy thing is things you put in the fetcher cache. It's easy to calculate its size. So you basically just store the size of these of stuff you put in the fetcher cache without watching the disk, because you know it once when you are fetching it down, and then you just do the math internally.
Right. So the GC policy is GC mechanism is slightly different. But yeah, I agree that we should definitely look into how. Yeah. Okay. Yeah, I think we should definitely look into like the fetcher cache size way, because we haven't discussed that in fact.
Does in general, does the image GC bring us closer to being able to unify images and fetch artifacts into a single store?
Not really. I think that the goal is trying to wrap this up ASAP and then move the developer resource to have a artifact store for those fetcher cache and layers, and we put more energy there. So this is like more like a stopgap solution.
Yeah,
to run this in production.
Yeah, and we did have the plan when we introduced the unified artifact store. We might move the fetcher cache and provisioner together, and to have the unified artifact store to control both container image and fetcher cache URI. So, and then we do a hash for them together. And at that time, we will introduce another GC way, another GC with different agent flag to control. So it might be a good hint to start to think about like to control the size of the.
Right. So another difficulty, I think another difficulty is like for to do the fetcher way is we don't really know the size of the layer. It's not like artifacts that you store those artifacts, you know the size of the file. But for this one, the layer, once you untar it, you don't really know how.
But you don't change that doesn't change, right? So
that,
you want to watch.
Yeah, I don't want to do a DU. I mean, how do you get the size for that entire layers? Like it's kind of a trade-off, right? So like either you have some way to magically figure out based on the tar file and the compression ratio to calculate the size of the layer, or you do DU, which is kind of expensive. If the layer is huge, then I expect it's going to take a long time to finish.
Cost can be absorbed because we still need to expand the content of the directory anyway. I wouldn't imagine DU is probably is linear to the size of the layer. It's just slightly higher multiplier to me.
Right. So my point is like we need to do more investigation, see how easy it is to do that. It's not as easy as just getting the size of the file.
Sure. DU is going to be proportional to the number of files, not to the size.
Right. Number of files. Sure. Yes.
And
tar too, I guess.
And for OCI in the future in Unified Artifact Store with the OCI support, we have the size of each layers. I think.
No, that's compressed. So that's tar, like that's the size of the tarball, not the size of the untarred layer. So we probably need to still think about how to solve that issue.
So I think some previous idea is try to slowly bridge the two disk related isolators and make them also cover either the store or the things in the store.
Yeah.
Right. Yeah. So I guess we should think about that. But even though I guess the point here is not about whether that can be unified or not. It's about right now we're basically relying on the operator or the user to be able to afford multiple disks to do hardware level isolation of disks, and you set aside this disk for this purpose and that for that purpose, but there are other things Mesos has which uses disk space. What if I just have a long? Yeah. Okay. I guess you get my point. Yeah.
Yeah. So I get the point. So I think there's a lot more we need to do. For example, the upper layer for overlay, we need to cap the size. That's another thing that we want to do. Things like this. So this is just like a stopgap solution to make it production ready. If you don't have GC, like even very simple GC policy, then it's not production ready, I think.
Have you considered a API to tell you if GC is going to do anything? Like, some kind of API to say, is there anything even available for GC? Is that something that would be useful in your workflow?
Oh yeah, so that's a good point. So I think we don't have that API right now, right, Gilbert?
We don't.
But that's pretty straightforward to expose, I guess.
I think what you're looking for, what Jen's looking for is the.
I thought so. When you previously mentioned the metrics, at least the metrics in a full API would be more useful.
Yeah,
but something fun there.
Yeah, it is. We can definitely introduce the API, but if you involve some interface, some new interface in the containerizer, which I might don't like because we don't have the image management at this point, and then if we want to introduce some like show GCable layer or show all layers, it is like kind of like we're gonna introduce some temporary solution. So why not we just do the image management altogether in the unified artifact store in the near future when we support the OCI. So that can be something we can do in the future.
Yeah, so Gilbert, I think like adding some metrics, if it's not hard to add those metrics, I would prefer just adding those metrics. It's always good to have more metrics than having like less metrics.
Yeah.
If it's easy, but if it's hard, you think it's hard, then it's okay. I think we should spend more energy on the unified artifact store because that's the direction that we think it makes sense in the future.
Yeah, yes. So for metrics, it sounds good to me. But for a new operator API to list all layers, I will say like we can definitely do it with the unified artifact store.
Yeah, I think metrics, if it's easy to get, like a gauge that you can easily get the like all the layer that you can potentially delete, the number of layers you can delete, things like this, that would be useful. Still.
Exactly.
Yep.
I think basic metrics that would serve that sort of purpose would be like how much you're consuming, as a gauge, how many times you ran the GC, how many things you cleaned up on each GC run, that kind of thing.
Right.
Yep.
All right, sounds good. Thanks, guys. I think we are over time. Thanks everyone for attending. So we probably have a demo for standalone container next time, and because the other code are committed, we're gonna follow up on the user namespace discussion and this one too.
Okay.
I guess you haven't sent out design docs. You have to send out design docs to the community, and then we can iterate on that.
Which decide out?
The auto GC, the flag you want to add.
Yeah, sure. We will send it out very soon.
All right, sounds good. Thanks, guys. Thanks, everyone. See you guys next time.
Thanks.
See ya.
Bye.
Take care.
Bye-bye.